Hello everyone, for this tutorial video I'd like to explain more exact factors that affect the inductance of an inductor, instead of just a general definition of what an inductor is. In particular, we remember from electromagnets that the more turns an electromagnet has, the stronger the field, so this logic should hold true for inductors as well. And we also saw that for electromagnets, the greater the area of the coil, the stronger the magnetic force, and the longer the magnetic coil, the weaker magnetic force it produces, and this exact logic holds true for inductors. And then we also remember how electromagnets can have different cores of different materials, so a material that magnetizes more easily, like iron, gives more inductance. So we conclude in a formula, L for inductance equals n squared times permeability times cross-sectional area all over length. But it is important to notice that this is only an approximation, because we remember how saturation and hysteresis were problems with magnets. And so it will be a problem in determining the amount of inductance in them as well. Because, as this formula makes clear, if the permeability is unstable, the inductance will be as well. But generally, most inductors are manufactured with an air core or something that does not saturate as severely, so that way the inductance is relatively stable, which is very important for high precision applications like in radio or in military equipment. In my next tutorial video, I like to explain how to predict total inductance of series and parallel inductances, instead of simply the inductance of one inductor, also exactly like the order I presented capacitors in. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.